One of the reasons why we decided to look at tipping points again was that the Washington Post just published actually a great article with lots of great visuals on all the tipping points. And of course, there's a lot of them. And it asked the question, which scientists have been asking for at least 10 years, how close are we to tipping? Well, we're past close.
Hello, and welcome to the Climate Emergency Forum. My name is Charles, and I'll be your host as we talk about the looming threat of climate tipping points. Climate tipping points are one of the most pressing issues and concerns of our time. As global temperatures continue to rise, the risk of triggering these critical thresholds increases, potentially leading to irreversible changes in our planet's climate system. Tipping points are not just isolated events. They're interconnected elements of the Earth's climate that, once crossed, can lead to cascading effects with profound impacts on ecological systems and human societies. From the melting of the Greenland and Antarctic ice sheets to the destabilization of the Amazon rainforest and the Atlantic meridional overturning circulation, these tipping elements could alter the state of our planet in ways that are difficult to predict and control. Recent studies suggest that even a global warming average temperature of 1.5 degrees C, a threshold which we have essentially reached as recorded over the last 13 consecutive months, with this July ending the streak by a hair at 1.48 degrees C. This threshold could trigger multiple tipping points, which underscores the urgency needed to limit further warming. We will explore the science behind these tipping points, their potential impacts, and the steps we can take to mitigate the risks. Our last program specifically on this topic was called Tipping Points in the Climate Casino, which was published last October, that is October 2023, where we focused on the OECD report called Climate Tipping Points: Insights for Effective Policy Action, which highlighted the significant risks associated with overshooting the 1.5 degrees C global average temperature threshold. That paper emphasized, or that report, I should say, emphasized that surpassing this limit could trigger several climate tipping points, leading to irreversible and severe changes in the climate system. Key concerns included the potential collapse of the West Antarctic and Greenland ice sheets and the rapid melting of Arctic permafrost, which would contribute to additional sea level rise and greenhouse gas emissions, exacerbating global warming. The report argued that the risk of crossing these tipping points should no longer be considered low probability and called for urgent emission reductions within this decade. It also recommended that climate policies incorporate strategies to manage the risks of tipping points through enhanced mitigation, adaptation, and technological innovation. In this program, we're going to expand on that discussion with a report that was released by the University of Exeter and led by Timothy Lenton that was published for COP28 called Global Tipping Points 2023. The report provided a broader assessment by considering both negative and positive tipping points in the Earth's system and society. It examined the cryosphere, the biosphere, and the circulation of oceans and atmosphere, as well as the interactions and potential cascades of these tipping points. There has since been further research released in 2024, which we'll also touch upon. And now I'd like to pass it over to Dr. Peter Carter. Peter, what can you share with us on the topic?
Well, the reality is that, particularly with respect to tipping points, that everything's getting worse, and it's getting worse faster. One of the reasons why we decided to look at tipping points again was that the Washington Post just published actually a great article with lots of great visuals on all the tipping points. And of course, there's a lot of them. And it asked the question, which scientists have been asking for at least 10 years, how close are we to tipping? Well, we're past close. And one scientist really answered this in a very accurate and proper manner. He's Nicholas Boyce of the Potsdam Climate Impact Institute. And what he said was, with every gram of additional CO2 in the atmosphere, we are increasing the likelihood of tipping points. And that really is an excellent quote, because that is how we have to be looking at it, not thinking that we can anticipate the tipping points in the future. Tim Lenton, he's the tipping point expert in the world, and I've got the greatest respect for Tim Lenton. He really is an excellent climate scientist in general. Now, in that report, in fact, he said that 3 or maybe 5 of the tipping points that they covered in that big report could be reached if the planet heats to 1.2 degrees C. And as you've just said, we're way above that now. A couple of years ago, it was 1.2, but now we're right up to 1.5. Another thing that Tim Lenton was quoted on a really good article that came out last summer, and it was an article on the extraordinary extremes of the 2023 summer. And what he said was, and people have told me about this before, is that these multiple extraordinary extremes suggest parts of the climate system are reaching tipping points. And Tim Lenton mentioned flickering. He describes that as when we are on the edge of a tipping point, and a particular state of the climate system is sort of going backwards and forwards a little bit. And when you look at what's been happening to regional temperature this year, I mean, absolutely crazy. Big cold regions and then suddenly superheated regions. Right now in the Canadian North, right through the Arctic Circle, there's extraordinary temperatures, and it's still heating more than anywhere else on the planet up there. So of course the Canadian fires are roaring again. I have one particular favorite paper on tipping points. It was published in November 2023, and the title was Committed Global Warming Risks Triggering Multiple Tipping Points. The lead author was Jesse Abrams. I'd recommend that paper to anybody because it's absolutely the best proper scientific way of looking at this, and particularly applying policy. So what the paper said was maintaining the heat in the system today would commit multiple parts of the climate system to passing tipping points. So even if we just maintain the present heating, then we're going to go over tipping points. The other big point was that only a lower emissions scenario avoids crossing most tipping points. Now, we're actually, because of the corporations and our governments and the world economy, we're actually tracking the very worst case scenario right now. So those are very important, but very sobering quotes. So one thing that I've been doing, particularly for many years now, and I know Paul Beckwith has as well, because that's actually how we met, I've been focusing on what is the greatest single threat to the planet and to our survival and having a livable planet. And that's up in the Arctic, because nearly all the largest sources of tipping points amplifying feedbacks, because a lot of those are the same, are up in the Arctic. I've been using the Copernicus satellite data, and I've watched them improve their satellites over the years. And now we get really good images of methane on the surface. And right now in the Arctic, we are in the absolute worst situation that I've ever seen. Arctic sea ice presently is tracking the record low of 2012. That's a huge change in the past couple of years, a great change in Arctic sea ice. And we have methane emitting from all of the Arctic methane sources. And that's a huge amount of methane. It's emitting from the wetlands. We know that's been happening for a few years because we know that the climate scientists discovered that that's what had accelerated atmospheric methane even faster than before. But a lot of wetlands are emitting a lot of methane in the subarctic regions. Also, and of course, this has been a fear probably for most of us for many years, also the Arctic permafrost is emitting methane, and it's emitting quite a lot. The other thing, which in a sense is of least importance because it doesn't emit as much methane as fast as wetlands. Wetlands, of course, emit methane very fast. They're called fast responders. The scientists had thought that we had lots and lots of time to wait and worry about permafrost, but we don't. We don't because of two excellent papers by Katie Walter Anthony. And one of them was a couple of years ago, in which the paper was on abrupt permafrost thaw. So that changed everything. It's not going to be just a slow thawing and the slow releasing of methane. Permafrost, by the way, is emitting methane now. It's because it's thawing. It's emitting CO2, much larger amounts of CO2 than scientists ever anticipated. It's also emitting the third big greenhouse gas, nitrous oxide. So there's really nothing worse on the planet than thawing permafrost. Of course, my great concern is that, and many others, that we have to use permafrost thaw as our guide to policy and attitude towards climate change. Because it's no good trying to figure out how close we are to tipping points when we've got the permafrost thawing. Once we had the permafrost thawing, and that was a number of years ago, then we should have said, okay, we got to flip into emergency mode right away.
Thank you, Peter. Thank you for sharing such a wealth of various references and various observations. And now I'm anxious to hear, Paul, what you have to share with us on the climate tipping points.
Yes, thank you. So the climate system is, of course, very highly nonlinear. When you have a change in greenhouse gases, a change in temperatures, it doesn't follow a linear curve. It follows more like a parabolic or exponential curve upwards. One of the main reasons for this nonlinearity is the multiple feedbacks and different cascading effects in the climate system. You can think of these feedbacks as chain reactions. There's an awful lot of accelerating feedbacks which make the warming much faster. More warming begets more warming, if you like. Peter's mentioned a lot of the different tipping elements in the climate system. And as both you and Peter have mentioned, the Tim Lenton from Exeter University website on global tipping points is an excellent resource to use. So I'll just talk about some of the specific ones. Of course, the polar glaciers, both in the Arctic, the Greenland ice sheet and also Antarctic ice sheet, are rapidly melting. And as they get warmer and there's more meltwater on the surface, then the albedo is lower, the reflectivity of the ice sheet is lower, so the solar absorption is higher. So the melting is accelerated. Greenland and East Antarctica are very concerning because they're well above sea level. So any ice melting there raises sea level. The Western Antarctic ice sheet is more vulnerable than the East Antarctic ice sheet, but a lot of it is grounded on the seafloor, well below sea level. So there's also lots of potential sea level rise inherent in that. Of course, the polar sea ice is a concern. We've tracked the Arctic sea ice, and as Peter mentioned, we're tracking near the record low year of 2012. Antarctic sea ice is surprised even more so than the Arctic in the last few years because it was generally rising slowly, and it's gone into sort of a collapse mode, being 4 or 5 standard deviations below normal. Of course, all of these things are disrupting the circulation patterns on the planet, which are basically the tipping points that affect everything else. They're connected to everything else. I'm talking about the ocean currents. We know that the Atlantic meridional overturning circulation is declining rapidly. We've also seen declines in the SMOC, the southern meridional overturning circulation ocean currents, or basically you can combine the two and call them the GMOC, the global meridional overturning circulation. So the ocean currents are not behaving as we would expect. They're slowing down, and this affects heat transfer from the warm equator to the colder poles. Of course, the atmospheric circulation is extremely disrupted. The jet streams have slowed, become much wavier, leading to many more extreme weather events and more intense extreme weather events like torrential rains leading to floods, which Canada has experienced in spades in the last month, both Toronto about a month ago, Montreal more recently. Large parts of Ontario and Quebec affected. These events are happening in regions where they didn't happen before. So, for example, the atmospheric circulation was different. So the remnants of Beryl about a month ago affected Toronto. The remnants of Debbie just more recently dumped huge amounts of rain in a short period of time on large parts of Quebec. So all of these things are going on. We're getting a lot more droughts and heat waves as a result of the very meridional wavy jet stream. And there's a very strong tipping point, I think, with heat waves, which is overlooked. The human body is only tolerant to a certain level to heat and humidity. We had a heat wave in Europe back in 2003, and it killed about 50, 60, 70,000 people. We've had similar heat waves in Europe recently that have probably killed that number of people. But one of the problems is, heat waves are a bit of a silent killer, the heat and humidity. And the cause of death, people are dying of heat waves, and the cause of death is often reported as a stroke or a heart attack. The problem with heat waves is that a little bit higher temperature, a little bit higher humidity, and instead of having 100 or 1,000 people dying in an event, multiply that by 10 or 100. We'll get mass casualties. And I spoke about heat waves in incarceration in the US, specifically in places like Texas and Louisiana. We're getting mass numbers of prisoners incarcerated in these prisons with no access to air conditioning and not sufficient water. And they're basically broiling to death in the prisons. There's multiple fatalities occurring, and they're not being reported as due to the heat waves. Like I said, they're being reported due to other factors. And this is like the prison basic systems basically killing people. It's like an imposed death penalty, death sentence on many, many people in these prisons. They're very vulnerable and they can't do anything. They can't move. They're stuck in cells. So this is a problem. There's favorable tipping points, and that is basically human agency, right? Like, ramping up electric cars, ramping up batteries. As you get more and more consumer buy-in, then you can get economies of scale. Economies of scale is basically a tipping point in the price, right? The price can plummet for goods and lead to mass usage. And of course, there is a body of statistics developing over tipping points, things to do with flickering or brittleness of a system. As you near a tipping point, the excursions, the swings go further and further, the frequency of oscillations decreases. You get something called a large increase in autocorrelation. So there are statistical methods to show that we're approaching tipping points, and the signs mathematically are not good for many of these climate systems that we've discussed.
Thank you, Paul, for sharing all those items and for bringing up the concept of human tipping points, the fact that the human body has a limit, and that limit is very nonlinear. Now I would like to turn it back over to Peter Peter, do you have any further insights you'd like to share with us about the climate tipping points?
So I omitted to mention the second of Katie Walter Anthony and team's shocks to the scientific community on research up in the Arctic. And I mentioned abrupt climate change thermokarst lakes, but there was an even bigger shock to us that she published just a few days ago. I can't remember the entire title because it's very long, but it's about Yedoma permafrost. So if you want to access it, just put in Yedoma permafrost and Katie Walter Anthony is bound to come up right away. So Yedoma permafrost has been the biggest of all the permafrost fears. However, up to present, up to last week, we figured that we didn't have to worry about Yedoma until towards the end of the century. Yedoma is the most ancient permafrost, goes back millions and millions and millions of years, and it comprises only about 25% of the permafrost, but it holds by far the most carbon. So if you're thinking about Arctic carbon time bombs, etc., Yedoma permafrost is probably more important than even methane hydrate. She discovered, yeah, that Yedoma was thawing, it was slumping, and it's emitting a heck of a lot of methane. I mean, a heck of a lot. The research that she was doing is up in Alaska, but of course, we got the whole of Siberia as well, which is about 2/3 of Siberia's permafrost. So I'll also mention just the methane hydrate because I know that we've been interested in that. Many people have been interested in that for many, many, many years. It is a slow responding methane feedback, but it is definitely venting right now. And it's venting from the Kara Sea and it's venting from the Laptev Sea. The Kara Sea, I discovered last year, is well recognized as a vulnerable site, continental shelf Arctic site for methane hydrate. I looked that up because last summer, the Kara Sea bed, the seabed of the Kara Sea was emitting methane. Now it's emitting even more methane, and now the Laptev Sea is emitting methane as well. All our friends and colleagues will probably remember that we've talked quite a lot about the excellent research by Natalia Shikova on the East Siberian Arctic shelf. So these are literally terrifying situations. They're terrifying in the sense of the future of all of our children today and the future of all humanity. It really, seriously, guys, it is terrifying. We've got methane hydrate, but oh my God, we've also got Yedoma emitting methane now.
Thank you, Peter, for that information, the Yedoma and the methane hydrate. I remember back in 2018, Stuart talking about the East Siberian shelf. I remember Stuart talking about that, and that was kind of like a big concern even back then, that would create a runaway effect. Now I'm going to turn it back to Paul. Paul, do you have anything more you can share with us about climate tipping points?
Yeah, I mean, we've had heat waves recently, both on the shores of the Arctic Ocean, our Canadian north, record temperatures in cities there and right along the coast. Of course, all this adds to thawing of the permafrost, which is underlying a lot of the land up there. And, that when that permafrost thaws and the organic material is exposed to oxygen and decomposes, we get CO2, or if it's submerged under the water and decomposes anaerobically, we're getting methane, contributing to the methane that Peter's talking about. Also, we've had heat waves in Antarctica. These heat waves are accelerating the potential for ice melt, although it's mostly, these heat waves are in the Antarctic winter, so the temperatures are still below zero, but the warm water is undercutting the ice, especially on the West Antarctic ice sheet, and greatly accelerating the melts there. So when we're talking about tipping points, I really like the analogy of just being in a canoe. It's one of the origins of that term, tipping point. If you're in a canoe, you know how tippy it can be, and if you lean to one side, you reach this point where the canoe will correct for a while, but if you go far enough over and lean far enough, then the canoe is like, it's like poised in no man's or no person's land. And a little bit more over and you're in the water, tipped over, a little bit back, and it rights itself. So you reach this threshold. It's a very strong threshold behavior for these tipping points. And whether they're accelerating climate change or whether they're accelerating human reaction to climate change, right? So it's like another good example is kind of like a chain reaction, right? I mean, if you think about nuclear fission, a neutron hits a nucleus, it breaks into two neutrons come out, each of those hit a nucleus, each of which generates another two, so you end up having 4 neutrons and so on. You get a cascading chain reaction effect, and then you have an out of control reaction. So you can use that as another analogy. And there's loads of other ones. And it seems that, with these increased temperatures and the increased amount of water vapor in the atmosphere, when that water vapor condenses, it provides huge amounts of energy to fuel these massive storms that we're seeing. The circulation patterns, I've talked about the ocean circulation and the atmospheric circulation, the jet streams, changing behavior. And of course, those interact with so many different other elements of the climate system. And we're seeing huge disruption, and we're getting a lot more meridional heat flow. So I'm talking about heat flow from the equator to the Arctic and heat flow from the equator to Antarctica, which is contributing to setting these huge temperature records. So the whole Earth system is changing, it's rewiring, if you like, and the heat is being distributed more uniformly with respect to latitude on the planet. And eventually it will lead to, what I've called for many years the blue ocean event. We'll get a, blue ocean event also in the southern hemisphere, and eventually the Arctic will become, it's heading back to a much warmer state, which we had in the paleo records many, long times ago in the paleo records, which we know from ice core measurements, from sediment core measurements, etc. So the climate system is very, very unstable. We've destabilized it, and we're passing thresholds in different elements, and they're tipping, and they can lead to cascading tipping, and it can make human life very miserable on this planet.
Thank you, Paul, for your insights on the topic and for reminding us of the criticality of the tipping points and the dire impacts. And so, once again, I just want to thank Peter and Paul and you, our audience, for joining us here today. And if you learned something from this video about, for example, climate tipping points, please consider liking the video. And if you haven't done so already, subscribing. And we look forward to seeing you again on the next Climate Emergency Forum.